In the final lesson of Section 4, we are going to revisit theoretical and experimental probabilities. In Section 3, in our look at these ideas, we only considered single events. Now, however, we will investigate theoretical and experimental probabilities as they apply to two independent events. We will use the concept of sample space to help us determine these probabilities. In this video, our sole focus will be on theoretical probabilities for two independent events. We now combine the ideas of independent events and our theoretical and experimental probabilities. We will consider two independent events. We will use the sample space, and I will obtain this sample space using a horizontal tree diagram or a table. You are certainly more than welcome to use any of the other visuals that we've discussed. And we'll use this to determine the number of favorable outcomes, the number of possible outcomes, and hence the theoretical probability. Recall, the probability of event 1 and event 2 occurring will be the number of favorable outcomes divided by the number of possible outcomes. So we are now dealing with two independent events. But our formula works the same way. Our first example, a spinner has four equal sectors, four equal sections, colored green, red, blue, and yellow. A die has 6 sides, which have been labeled 1 to 6. The spinner is spun and the die is rolled. The first thing we will do is determine the sample space. And now we have a question. What is the theoretical probability of spinning the color green and rolling an even number? Our first event is the spinning of the spinner. Our second event is the rolling of the die. To obtain our sample space, we are going to use a table. And remember, the sample space gives us all of the possible outcomes. I have the spinner possibilities put on the left, red, blue, yellow, green, and I have the die possibilities listed at the top, 1 to 6. In using our table, it is relatively easy to determine all of the possibilities. I have red and a 1, red and a 2, red 3, red roll a 4, spin a red roll a 5, spin a red roll a 6. And I will complete the table in this manner. And in my final row, I can spin a green, roll a 1, spin a green, roll a 2, spin green, roll a 3, spin green, roll a 4, spin green, roll a 5, or spin green and roll 6. That's our sample space. Now we go back to our question and we focus in on this. What is the probability of spinning green and getting an even number? Our attention should go to the row with the green, and our even numbers would of course include 2, 4, and 6. We want basically the overlap of that row and the columns. I have 3 possibilities of spinning a green and an even number. I can then write probability of green and even. Favorable outcomes, there are 3. Total number of outcomes, 24. My probability written as a fraction then is 3 over 24, which can reduce to 1/8. I could express my answer as a ratio, 1 to 8. As a decimal, 1 over 8 is 0.125, and as a percentage, that would be 12.5%. In other words, there's a 1 in 8 chance of spinning green and an even number. Our second example, a quarter is flipped once and then flipped a second time. These are two independent events. We will determine the sample space. This time we're going to use a horizontal tree diagram. And our question, what is the theoretical probability of flipping 2 heads in a row? Let's get our sample space. My flip 1 can be heads or tails. Then for my flip 2, I need 2 branches coming from each of those possibilities. to give me heads or tails on the second flip. From that, we get our outcomes. Heads and heads, heads and tails, tails and heads, tails and tails. Only 4 outcomes here. We want to know the theoretical probability of getting 2 heads in a row. Favorable, right here. Just the 1. Total number of outcomes, 4. Our probability of flipping 2 heads, 1/4. As a ratio, 1 to 4. As a decimal, 0 25 hundredths. As a percentage, 25%. How do you know in which form to express your answer? Well, sometimes you'll be asked in the question to express it in a certain manner. If there is no form specified in the question, you can choose whatever form you want. And our last example. The birthday menu at Ron Cherry's offers 3 beverage choices and 4 meal options. The drinks include milk, juice, and soda. The meal options include chicken and mashed potato, hamburger with fries, an 8-inch pizza, or a whistle dog with fries. Whistle dogs are amazing. We will determine the sample space, and then our question. What is the theoretical probability of selecting a milk and a meal option that includes fries? Right away, I want us to look at the fact that the whistle dog is served with fries and the hamburger is served with fries. Let's get our sample space using a horizontal tree diagram. For my beverage, I have 3 possibilities: milk, juice, soda. I have 4 branches coming out of each of those because we have 4 possible meal options. And I've abbreviated these as well. CMP for chicken and mashed potato, H and F for hamburger with fries, P for the 8-inch pizza, and WDF for the whistle dog with fries. So we have those 4 possibilities for our milk, those 4 possibilities if served with juice, and the same 4 possibilities if served with soda. From this, we can now get our outcomes. Milk, chicken and mashed potato. Milk, hamburger and fries. Milk, pizza. Milk, whistle dog with fries. And I complete the tree diagram accordingly. Soda with pizza, soda with a whistle dog and fries. Back to our question. The theoretical probability of selecting milk, and we need an option with fries. The number of favorable outcomes here, we have milk and the hamburger with fries, or we have milk and the whistle dog with fries. Therefore, we have 2 favorable outcomes, and there are 12 outcomes in total. As a fraction in simplest form, that would be 1/6. A ratio, 1 to 6. As a decimal, that would be 0.16, and the 6 is repeating. And as a percentage, 16.6, with that 6 repeating, %. Any of those meal options would taste pretty good right now. And now I would like you to proceed to the next video in this lesson.